Our Earth is called the Blue Planet, as more than 70% of the Earth's surface is water-covered and holds about 97% of all Earth's water. Our knowledge of the ocean is limited, especially considering the fact that more people have gone into space on various missions, while only 3 people have descended to the deepest part of the ocean, the Mariana Trench in the Pacific Ocean. Taking up this challenge of exploring and sustainably harvesting the vast resources of oceans, the Department of Ocean Development, now the Ministry of Earth Sciences, Government of India, established National Institute of Ocean Technology (NIOT) in November 1993 at Chennai, with a mandate to design, develop, demonstrate and utilize ocean technologies for the benefit of the country.
National Institute of Ocean Technology is the technical arm of Ministry of Earth Sciences and the only civilian institute in the country working in the area of ocean technology. For the past 2 decades, we have been working in this area relentlessly, and the success of many projects are well known to the country. We also have done lot of activity in the area of ocean energy, which is a renewable one, and also in desalination.
Water is such a precious and scarce resource on the islands of Lakshadweep, and NIOT's low-temperature thermal desalination-based technology plants developed and established at Kavaratti, Minikoi and Agatti. Presently, similar LTTD plants in another 6 islands of Union Territory of Lakshadweep, which includes Amini, Androth, Chetlat, Kadamat, Kalpeni and Kiltan Islands, is underway. The plants are technologically user-friendly and is being operated by the local people. The availability of clean drinking water has substantially reduced the occurrence of waterborne diseases in these areas. Adopting the concept of reduce, recycle and reuse of the Government of India, NIOT has developed a technology for desalination using the condenser reject water available in thermal power plants at the North Chennai Thermal Power Station NCTPS, and the other in Tuticorin Thermal Power Station is underway. The Institute strives to achieve desalination using ocean thermal energy to make economically affordable water of good quality. A priority project has been proposed at Kavaratti Island in Lakshadweep using ocean thermal energy conversion (OTEC). For hands-on understanding of the ocean thermal energy conversion cycle, a laboratory scale of OTEC plant has been set up at the Chennai campus with a 2 kilowatt power module combined with desalination. Through the continuous efforts of the Institute, India has now become the member of International Energy Agency's Ocean Energy Systems (IEA OES), with NIOT being the designated agency. The Institute focuses on harnessing the ocean renewable energy in the form of waves, currents and temperature gradient. The floating wave-powered device called the Backward Bent Ducted Buoy (BBDB), based on the principle of oscillating water column, successfully generated power during the tests at the open sea. The wave-powered navigational buoy, also based on the principle of oscillating water column, has been fabricated and successfully tested near Kamarajar Port at Chennai. For harnessing electrical energy from the ocean currents, various straight and helical blade turbines were fabricated and tested. The straight-bladed turbine was then tested at South Andaman on a specially designed floating platform and towed for 48 kilometers. This successful trial, when the turbine generated 300 watts of electricity, more than expected output, paved the way for scaling up of 1 kilowatt turbine for off-grid units at Andaman. The Institute has taken up initiatives in development, fabrication and installation of systems in offshore wind sector using LIDAR-based data collection platforms. A platform was successfully installed at Gulf of Kambat for Ministry of New and Renewable Energy National Institute of Wind Energy MNRE, which is the first of its kind in Indian waters. An initiative to extract biofuel from algae has been successful. Test run of biodiesel B10 powered vehicle from Nellore to Chennai was completed successfully. For the ground truth validation of gas hydrate occurrences and to quantify the resource in the Indian waters, NIOT acquired the technology for an underwater wireline autonomous coring system ACS. The system has been qualified for 3,000 meter operations and drilled up to 40 meters below the seafloor at 850 meter water depth. Further trials and coring at KG Basin site are on the anvil.
Some of the societal activities which we take up are ocean observations, wherein we put up lot of data buoys in the ocean which measure the parameters and send it to Indian Meteorological Department for effective weather prediction. In the area of coastal protection, we take up sustainable protection measures like in the case of Pondicherry, Kadalur Periyakupam, Visakhapatnam, etc. We have got a large group to develop indigenous technology. Many technologies which we have developed at the institute have been transferred to the industry successfully, and this gives the Indian industry a name through Make in India program.
In order to augment our understanding of the ocean processes and their implications of the climate and natural hazards, the Institute has set up a real-time monitoring system for obtaining reliable data relating to different oceanographic and meteorological parameters such as waves, currents, temperature and salinity. Through a network of data buoys, which includes 19 moored buoys in the monitoring of the Indian seas and 1 buoy at the Arctic seas. Under the Indo-US collaboration, the Institute supports RAMA buoys network of 25 moorings in Indian Ocean under the Global Ocean Observation Program. The Institute's tsunami buoys plays a crucial role in warning the Indian coast against tsunamis by providing real-time data on ocean parameters. The data captured by the tsunami buoys are transmitted through satellite to the Automatic Data Reception Center at the campus, and finally is disseminated to INCOIS for operational purposes. The Institute's observational network is further strengthened by the high-frequency radars established along Andaman and Nicobar Islands, Andhra Pradesh, Gujarat, Odisha and Tamil Nadu for continuous observation of large-scale oceanographic measurements like coastal currents and waves. INDARC, the first ever Indian underwater moored observatory in polar waters to study climate change, was established by NIOT and NCAOR at Kongsfjorden, 1,000 kilometers away from the North Pole Basin. Also, a new ambient noise measurement system along with INDARC mooring was successfully deployed and is now operational in Arctic waters to study the ice dynamics, bioacoustics and sound propagation in polar regions. Further, to enhance the ocean observational network, the Institute has successfully developed the 2,000 meters water depth autonomous underwater profiling drifters and the drifting buoys Pradyu with INSAT communication. The other indigenous innovations developed in-house include the Aquabot, Variable Buoyancy Aquatic Glider, Robo-Coastal Observer, 6 variants of Data Acquisition System for data buoys, Portable High-Power Wideband Acoustic Transmitter for sub-bottom profiling, and miniaturized hydrophone arrays for underwater applications. The Institute has successfully transferred the technology to the industry of many of these systems developed in-house. The Institute has accomplished more than 200 projects along the Indian coast to cater to coastal infrastructure development with real-time observation, numerical modeling and engineering solutions. The Institute plays a major role in the Kalpasar project, one of the major initiatives by the Government of Gujarat, which includes field investigation activities at Gulf of Khambat. Further, several port infrastructure development projects and port layout studies in various environmental conditions were successfully executed at Andhra's Krishnapatnam and Gujarat's Pipavav port. The Institute has contributed majorly to the society by restoring the lost beach at tourism-rich Puducherry by constructing submerged triangular wedge-shaped reef structures along with beach nourishment that led to the formation of beach of width about 60 meters near the new pier. Shoreline mitigation activities have also been carried out at Ramakrishna Beach, Visakhapatnam and Kadalur Periyakuppam off Chennai coast, using submerged dike which helps dissipate the energy of larger waves without completely blocking the waves. The Institute has developed and published the first of its kind online coastal statistics that include the Technical Criteria Atlas, a digital wave atlas with 50-year return period statistics, a real-time oceanographic data portal, port monitoring system, and storm surge web portal disseminate for the benefit of various stakeholders. The Institute designed and fabricated and demonstrated open sea cages for culture of finfishes and successfully implemented the same at North Bay, Port Blair, Olaikuda, Tamil Nadu and Kottachatram and Tuplipalam in Nellore, Andhra Pradesh. The Institute shares the nation's vision on blue economy and strives to develop technologies that utilize the vast resources of the oceans to address the problems of resource scarcity and enhance the livelihood of the coastal communities. In a bid to improve the fish catch, 28 fish aggregating devices, FADs, were deployed around Lakshadweep Islands, and 750 artificial reef structures were designed, fabricated and deployed along Odisha coast.
Coming to the niche areas, we work in the deep sea technology. We have a mandate set by the International Seabed Authority wherein we have to develop the technology to take out manganese nodules from deep sea from a depth of 6,000 meters. We are in the process of setting up an underwater crawler which will move on the seabed and mine these manganese nodules which contain cobalt, nickel, etc. which are of strategic importance. We have done lot of work in deep sea. We have developed a remotely operable vehicle which also can go to 6,000 meters and also soil tester which can measure the soil property in situ at a depth of 6,000 meters. As part of the deep ocean mission, we are having a major project to develop a manned submersible capable of taking 3 human beings up to a depth of 6 kilometers down to explore the ocean at that particular depth.
The major non-living resource that the oceans offer are polymetallic nodules, cobalt-rich manganese crust and hydrothermal deposits. As a pioneer investor, India has been allotted 75,000 square kilometer area in the Central Indian Ocean Basin CIOB by the International Seabed Authority towards exploration and technology development for polymetallic nodule mining at 6,000 meters water depth. As a milestone effort and part of the technology development for the deep sea exploration, a remotely operable in situ soil tester was developed for 6,000 meter operations. Soil property measurements have been carried out at 5,462 meter water depth in the Central Indian Ocean Basin. The augmentation of the deep-sea crawler with collector crusher has been developed and tested at the sea by pumping artificial nodules laid on the seabed. Efforts are on to develop crawler-based mining machine for 6,000-meter depth. As part of the deep-sea exploration program, the 6,000-meter depth-rated deep-water remotely operated vehicle ROV was designed, developed and successfully demonstrated at the Central Indian Ocean Basin at 5,289 meters for mineral exploration. The system was demonstrated for hydrothermal sulfides exploration at the Central Indian Ridge in the Indian Ocean near the Rodriguez Triple Junction at 2,800 meters depth. Further, the scientific exploration of gas hydrate was conducted with the ROV at a depth of 1,037 meters and 1,019 meters in Krishna Godavari Basin in Bay of Bengal. NIOT scientists deployed the indigenously developed Polar ROV during the recent scientific expedition to Antarctica. The vehicle was deployed at the new Indian Barrier ice shelf region up to 62 meters water depth. The Polar ROV was further used for coral reef expedition in the Andaman and Nicobar Islands of India. A buried object detection sonar system capable of finding targets buried in the seabed for civilian and various other applications has been indigenously developed in-house. The Institute is in the process of developing a manned submersible with a depth rating of 6,000 meters to aid direct human intervention. A mock-up sphere treated as an acclimatization chamber has been developed for testing various parameters.
In the area of underwater communications, acoustics is the only medium for communication. We are developing various instruments for underwater communications as well as measuring the various parameters of the ocean in the deep sea.
The Institute's current research focus is on ocean ambient noise measurement passive acoustic systems for oceanographic and surveillance applications, sound propagation and ambient noise modeling, acoustic communication, seabed characterization and bioacoustics. Ambient noise is the prevailing sustained background sound in the ocean, wind wave activity, rainfall, shipping and biological species. A totally indigenous, automated ambient noise measurement system with a vertical linear array of 21 omnidirectional hydrophones and a real-time communication has been developed for time series measurements, ambient noise stations at Goa, Cochin, Chennai, Visakhapatnam, Kakinada and Kadalur have been established.
Our institute has got excellent collaboration with similar international laboratories like JAMSTEC in Japan, IFREMER in France, Woodsole Oceanographic Institute in the USA. We also have collaborations with many of these international labs.
NIOT's state-of-the-art and sophisticated infrastructure facilities include the hyperbaric chamber for simulating the pressure in the deep-sea environment, a soft soil seabed facility, an acoustic test facility credited with international standards, the underwater electronic support facility and the ocean observation systems calibration facility. The Institute's ice-class ocean research vessel Sagar Nidhi and buoy tender vessel Sagar Manjusha add impetus to the coastal research activity. The Institute's novel deep-sea microbial culture facility, mass culture systems, DC-powered electroflocculation system and a pilot-scale production of nutraceuticals adds a great strength to the Institute's marine biotechnology programs. As part of Niti Aayog project, establishment of a ballast water treatment technologies test facility is in progress on the east coast of India at Pamanji village of Nellore district in Andhra Pradesh. An An upgraded state-of-the-art field laboratory facility, Atal Center for Ocean Science and Technology for Islands, provides services by developing Island Resource Information System and EIA activities.
Oceans also will become a strategic issue for the country, like what we had in space as well as atomic energy 30 years back. And because of strategic importance for the oceans, no other country will share the technology with us. We have to develop ocean technology ourselves. This indigenous technology development should be made. So NIOT will play a pivotal role to make this kind of development for the country. As far as deep ocean is concerned, we know very little about deep ocean. For example, only 5% of the deep ocean has been already explored. 95% of the deep ocean is unexplored. So the deep ocean mission will definitely give an opportunity for exploring further insights to the deep ocean, to understand the complexity of the deep ocean, and also to harness the resources from the deep oceans.
NIOT scientists have won accolades in the area of ocean technology and have many patents and high-impact journal publications to their credit, and hold a niche place for themselves in the field of ocean technology. Today, NIOT, fully aware of the long road ahead, recommits itself to identify new challenges and future requirements in the field of ocean technology, so as to optimally use the ocean and its vast resources to support the nation in achieving self-sufficiency in food, water, and energy.